If a human were to see some planets in space for the first time, they might think they look beautiful. Huge glowing spheres, bright clouds, massive atmospheres. But beauty in space is almost always an illusion. And the closer we study other worlds, the more we understand how much the universe seems to reject life. On Earth, we consider 50 degrees Celsius extreme. People begin to lose consciousness. Machines overheat. Cities can literally melt under the sun. But in space, there are planets where the temperature is so high that not even asphalt survives. Only solid rock begins to melt. There are worlds where the surface is heated to several thousand degrees. There is no familiar ground, no oceans, no air to breathe. Instead, the surface looks like an endless sea of molten stone. Huge waves of lava move across the planet like an ocean on Earth. Only each of these waves is hotter than any volcanic lava ever seen by humans. But temperature is only the beginning. On some planets, the atmosphere is so dense and toxic that a human would die almost instantly, even with protection. The clouds there are not made of water, but of poisonous chemical compounds. The pressure is so extreme that the human body simply could not survive it. Some scientists compare these conditions to trying to survive at the bottom of an ocean under kilometers of water. Only instead of water, there would be superheated toxic gas all around. And yet there are places that are even worse. On one of the well-known exoplanets, it rains glass. This is not an exaggeration and not a beautiful metaphor. Because of extreme temperatures, minerals in the atmosphere turn into particles of glass. And then the strongest winds accelerate them to incredible speeds. This kind of rain would not just cause pain, it would literally cut everything in its path. But the most terrifying part is not the rain itself. Winds on such planets can move faster than the speed of sound. Imagine a storm that never ends. A hurricane so powerful that entire clouds of molten particles are rushing through the atmosphere like a giant sandblasting machine. And all of this happens constantly, without stopping. Some worlds are so close to their stars that a year there lasts only a few Earth days. Because of this, one side of the planet is always facing the star. There is never night on that side. Temperatures are so high that even metal would start to glow red. The sky could look like a massive wall of fire. And on the other side, there is absolute darkness and freezing cold. It is like two different planets merged into one. On one half, there is eternal hell. On the other half, there is eternal night. But even these conditions do not make these worlds the strangest ones. In the universe, there are planets that drift freely through space without any star at all. They are called rogue planets. They travel through the cosmos completely alone. On these worlds, there is no sunlight, no sunrise, no familiar sky, only endless black emptiness all around. If a human were standing on the surface of such a planet, they would see one of the most terrifying landscapes in the universe. Absolute darkness, maybe a faint glow from distant stars, and the feeling that there is absolutely nothing around for billions of kilometers. But the most disturbing part is that some of these worlds can be larger than Jupiter. Giant dark objects slowly moving through space like lost cosmic ghosts. Sometimes it feels like nothing could be worse. That planets with lava, oceans, and glass storms are the limit of nature's cruelty. But the real horrors of the universe begin only after the death of stars. When a massive star reaches the end of its life, one of the most violent processes in the universe begins. For millions of years, the star holds itself together only because of the enormous energy inside its core. But at some point, the fuel runs out, and then the balance collapses. Within seconds, the star begins to die. First comes the collapse. The entire mass of the star rushes inward at incredible speed, and then an explosion happens that can outshine an entire galaxy. This is called a supernova. For a short moment, a dying star becomes brighter than billions of other stars combined, but the most terrifying part comes after the explosion. Sometimes the core of the star does not disappear completely. It gets compressed so violently that atoms themselves start to break apart under the pressure. Electrons and protons merge together. Matter turns into something almost impossible to comprehend. This is how a neutron star is born. From the outside, it can look relatively small. Some neutron stars are only the size of a normal city, but inside this tiny sphere lies a mass greater than the sun itself. The density of a neutron star is so extreme that the human mind simply refuses to fully accept it. Just a single spoonful of its material would weigh billions of tons. A tiny fragment would be heavier than a mountain. If a neutron star somehow appeared near Earth, the consequences would be catastrophic even before any direct collision. Its gravity would begin to distort planetary orbits. Oceans would rise in gigantic waves. The atmosphere would become unstable. And then the Earth itself would start to stretch under the immense gravitational force. But gravity is not the only thing that makes neutron stars terrifying. Some of them rotate at insane speeds, so fast that they complete hundreds of rotations every second. Imagine an object heavier than the sun spinning faster than a kitchen blender. The surface of such stars moves at extreme velocity, while powerful streams of energy are thrown into space. These objects are called pulsars. From their poles, beams of radiation are constantly emitted. When such a beam passes near Earth, scientists detect a short pulse like a beacon flashing in the darkness of space. This is why pulsars were once thought to be something almost artificial. Some researchers even considered the possibility that they could be signals from extraterrestrial civilizations. But the reality turned out to be far more terrifying. A pulsar is not trying to send a message. It is simply slowly destroying everything around it. If a planet gets too close to such an object, radiation would literally burn away its surface. The atmosphere would disappear. Any form of life would be wiped out. And all of this would happen without an explosion, without fire, just a constant stream of lethal energy. But even among neutron stars, there are objects that scientists consider true monsters. Magnetars. These are so extreme that nearby physics itself starts to look broken. The magnetic field of a magnetar is so powerful that it is almost impossible to fully imagine. It is trillions of times stronger than Earth's magnetic field. If a normal magnet can attract a piece of metal, a magnetar can change the very structure of matter itself. At a distance of thousands of kilometers, a human would die before even realizing what is happening. The magnetic field would begin breaking down the atoms inside the body. Electronics would stop working instantly. Molecules would start behaving in unstable ways, and all of this would happen in complete silence. Even from very far away, a magnetar can damage entire planets. In the early 2000s, scientists recorded a burst from a magnetar that briefly affected Earth's atmosphere despite the enormous distance. And this is what makes it truly terrifying. Because these objects exist right now. Somewhere in the darkness of space, stars are spinning that can destroy everything living without even getting close to it. But despite all their power, magnetars are still only small objects compared to what is hidden in the centers of galaxies. At the center of almost every galaxy, there is something enormous, something so massive that billions of stars orbit around it. And the more scientists studied these regions, the more they understood that this is where the most dangerous objects in the universe are hiding. Supermassive black holes. Some of them are billions of times heavier than the Sun. They cannot be seen directly because light itself cannot escape their boundaries, but we can see the effects of their existence. And those effects look like a true end of the world. When gas, or even an entire star, gets too close to a black hole, one of the most violent processes in the cosmos begins. Matter starts spinning around the hole at extreme speed. It collides with itself. It heats up to unimaginable temperatures, and it slowly turns into a glowing disk that can outshine entire galaxies. This is how a quasar is born. Quasars are so bright that their light travels across billions of light years. Some of them started shining before Earth even existed, and only now their light is reaching us. This means that when humanity observes a quasar, we are literally seeing the ancient universe. But the most terrifying part is not their brightness. From the centers of quasars, enormous streams of energy are released. Giant plasma jets shoot into space at almost the speed of light. Sometimes they stretch across distances larger than entire galaxies. Everything caught near them is slowly destroyed by radiation and extreme heat. If such a jet were aimed at Earth, life could disappear even without direct impact. The atmosphere would begin to break apart. Radiation would destroy entire ecosystems, and the planet would turn into a dead rock. But even quasars are only a side effect of something far more terrifying: black holes. There is probably no other object that frightens people more, because a black hole feels wrong, as if the universe itself created a place where the usual laws simply stop working. The boundary of a black hole is called the event horizon. It is the point of no return. Everything that crosses it disappears forever, even light. If a human started approaching a black hole, at first nothing unusual would happen, but the closer they got, the stranger the world would become. Stars would begin to distort, light would bend into rings. Space itself would stop looking normal. And then the most terrifying part would begin. Gravity near a black hole does not act evenly. The closer part of your body is to it, the stronger it is pulled. Because of this, your feet would feel a stronger force than your head. Your body would slowly stretch more and more until it becomes a long, thin line of matter. This process sounds almost absurd, but scientists really call it spaghettification. And the most disturbing part is that for the person experiencing it, everything would feel normal from their own perspective. Meanwhile, to an outside observer, it would look completely different. They would see you slowing down near the event horizon, slower and slower, until you appear to freeze in time. But for you, time would continue normally. This means that near black holes, it is not only space that breaks down, time itself begins to break. Some scientists believe that inside black holes, there may be regions where known physics completely stops working. There are hypotheses about tunnels to other parts of the universe, about white holes, about new dimensions, but the truth is that no one really knows what is inside, because no information ever comes back. And perhaps this is exactly what makes black holes so terrifying. Not their size, not their power, but absolute uncertainty. But even black holes are not the most common threat in the universe. There is something that slowly fills the entire cosmos and can kill without being seen. This threat does not look like a monster. It has no shape, no color, no sound, and yet it is almost everywhere. Cosmic radiation. It is created in many different processes across the universe, in exploding stars, in particle collisions, in powerful eruptions on stellar surfaces. Sometimes it travels through space for billions of years before it ever meets anything at all. And the most dangerous thing about it is that it cannot be felt. If a human were left in open space without protection, nothing would look unusual. The surrounding universe would still appear calm. But at that moment, streams of energy would begin passing through the body, slowly destroying cells from the inside. On Earth, we are protected. The atmosphere acts like a shield. The magnetic field deflects most of the dangerous radiation. But in space, this protection does not exist. That is why even a short time outside a planet becomes deadly without technology. Solar flares are especially dangerous. Sometimes, the sun releases massive streams of particles into space. If such a flare were directed toward a spacecraft, it could damage electronics and put the lives of the crew at risk. But even more extreme events happen far beyond our solar system. Gamma-ray bursts are among the most powerful energetic events in the universe. They occur during the death of massive stars or the collision of extreme cosmic objects. In just a few seconds, such a burst can release more energy than the sun will produce over its entire lifetime. And if such a beam were directed toward a planet from a close enough distance, it could completely sterilize its surface, not destroy it, but strip it of any ability to support life. And yet, even radiation is not the most disturbing part of space, because there are places where almost nothing happens. No stars, no explosions, no movement, only emptiness. Intergalactic voids. These are enormous regions of space between galaxies. Their scale is so vast that light needs millions of years just to cross them. And inside them there is almost no matter. Very few stars, almost no galaxies. Only rare particles and absolute darkness. If a human were to find themselves in such a region, they would not see the familiar universe filled with objects. Instead, there would be almost nothing at all. This is not emptiness like an empty room. It is emptiness like the absence of structure itself. And there is something deeply unsettling about that. Because the universe does not just become dangerous, it becomes lonely. And the further scientists look into these regions, the more they realize that even there, things do not end. Because beyond the visible structures, there are objects that exceed everything in scale, so enormous that they influence entire galaxies. Hypergiant stars. Hypergiants are true monsters of the cosmos. If the sun already seems huge to us, hypergiants completely destroy that sense of scale. Some of them are so large that if placed in our solar system, their surface could extend out to the orbits of the nearest planets. They are not just big, they are unstable. These stars live fast and die violently. Inside them, a constant struggle takes place between gravity trying to compress the star and energy trying to push it apart. Because of this, hypergiants literally tremble. Their surfaces constantly shift. Massive eruptions throw enormous clouds of material into space. Some of them lose mass so quickly that giant nebulae form around the star made of its own material. It looks like a slow destruction of a giant happening in real time. And the most dangerous part is that this is not a peaceful death. Hypergiants end their lives catastrophically. Their inner core can no longer withstand the pressure and collapse begins. In just seconds, the entire structure of the star falls apart. And then an explosion occurs so powerful that it can outshine entire galaxies. This is no longer just a supernova. It is an event that scientists sometimes call a hypernova. After such an explosion, what remains is either a neutron star or a black hole, meaning the final stage always leads to something even more extreme and dangerous. And this creates a strange picture. The largest stars in the universe live fast and die in a way that creates the most terrifying objects in space. But even hypergiants are not the final point of cosmic horror. Because after all these explosions, after all the black holes and voids, there remains a question that scientists still find deeply unsettling. What happens next? The universe is not static, it is expanding. Galaxies are slowly moving away from each other. Light becomes weaker. And if we look far enough into the future, the picture becomes even more disturbing. Stars will gradually fade. New ones will stop forming. Galaxies will grow darker. And an era will come when the cosmos turns into a cold, almost empty space. This state is called the heat death of the universe. At that point, there will be no sources of energy, no light, no familiar processes, only slowly expanding darkness. And perhaps the strangest thing about all of this is not that the universe is dangerous, but that it is both incredibly beautiful and completely indifferent to everything living inside it. We exist in a space where every phenomenon, from a small planet to a massive black hole, follows the same set of laws, and those laws do not care about us. They simply exist. And this is what makes the cosmos truly terrifying, because there is no evil intent, no goal of destruction, no enemy, only processes that unfold for billions of years without stopping. Gravity compresses stars, energy tears them apart, space expands, matter gathers into new forms and breaks apart again. Everything repeats over and over on a scale that the human mind can barely comprehend. And within all of this, there is an observer, us. Planet Earth looks calm only because we were lucky enough to end up in a rare place where conditions allow life to exist. But this is not a guarantee, it is a temporary state. On cosmic scales, it can change at any moment. Sometimes a single event is enough. A supernova explosion happening close enough, a powerful burst of gamma radiation passing through space, changes in the orbit of a planetary system, or even slow processes stretching across millions of years. And then the familiar picture of reality disappears. But the strangest part is that most of these processes go completely unnoticed by us. They happen too far away, too slowly, or sometimes too fast for the human mind to fully grasp. The universe was not created for human perception. It does not adapt to our understanding. And because of that, every new discovery does not make it clearer. It only makes it more mysterious. The more we learn, the more questions appear. Why do such extreme objects exist? Why is matter capable of forming such states? Why is the universe built in a way that allows both life and complete destruction to exist at the same time? And we still do not have final answers to these questions. Only theories, models, observations, and attempts to build a partial picture of reality from them. But even that picture shows one thing clearly. We live in a universe where beauty and destruction are not opposites. They are part of the same process. Stars are born inside clouds of gas and dust. They live, then they die, and their death becomes the beginning of something new. New stars, new planets, perhaps new worlds where life can appear again. And this completes a cycle that has been going on for billions of years and may continue far longer than we can imagine. So when we look at the night sky, we are not just seeing distant points of light. We are seeing the history of the universe, a history in which every glow may one day become destruction, and every destruction may one day become a new light. And if we continue looking even further into the universe, it becomes clear that even this endless cycle may have an end, because the structure of space itself is changing. Galaxies are moving away from each other faster and faster. Space is stretching. Light from distant objects becomes weaker with every billion years. And at some point, an observer anywhere in the universe could end up in near complete isolation. They would no longer see other galaxies. They would not see distant explosions. They would not even see traces of the processes that once shaped the cosmos. Only their own galaxy would remain, and within it, slowly fading stars. But even that is not permanent. Over time, stars will stop forming. The gas that once created new ones will be exhausted. Old stars will burn out one by one, and each new era of the universe will become darker than the previous one. This is not an explosion, not a catastrophe in the usual sense. It is a slow fading. This is why scientists call it the heat death of the universe, a state where energy is so evenly distributed that no motion can be created anymore. No light, no change, no events. Only a cold, expanding space. But even in this picture, there is something strange. Because the laws of physics still continue to work, particles still exist, quantum processes do not fully stop, the universe does not disappear, it simply becomes almost empty. And this leads to the main question that still has no answer. Has the universe always been this complex and dangerous? Or is this just one stage in a much longer story? Some theories suggest that beyond the observable universe there may be other regions, perhaps even other universes with completely different laws, where stars do not die like ours, where black holes behave differently, or where matter itself follows different rules. But for now, these are only hypotheses, and our reality remains what we can observe. Huge, cold, beautiful, and at the same time deadly. And perhaps the most important realization is something else. We are not separate from this cosmos. We are part of it. The atoms in our bodies were once born inside stars. The oxygen we breathe was created in their cores. The iron in our blood came from supernova explosions. Everything that makes us alive once existed inside stellar processes. And when we look at the universe, we are in fact looking at our own past and our possible future. Because the cosmos does not just surround us. It is what we are made of.